Rocks. Types of rocks. And the rock cycle.
A rock is a naturally occurring solid mixture of one or more minerals, or organic matter. Rocks are classified by how they are formed, their composition, and texture. And rocks change over time, through the rock cycle. Rocks are different from minerals. Rocks are composed of one or more minerals, while minerals are composed of one or more elements or compounds. Rocks are identified by their characteristic mineral composition. Minerals identified by their characteristic chemical composition. Limestone is a rock, made of minerals calcite and dolomite. The mineral calcite is composed of calcium carbonate, while the mineral dolomite is composed of magnesium carbonate. Another example, granite is also a rock, made of minerals quartz and feldspar. The mineral quartz is composed of silicon dioxide, and the mineral feldspar is composed of potassium aluminum silicate. Rocks are classified into three groups, by how they are formed. Igneous rocks, formed from molten rock that cools and hardens. Sedimentary rocks, formed from sediments, or pieces of other rocks, that are cemented together. Metamorphic rocks are formed when old rocks are changed by heat and pressure. Igneous rocks, named from ignis, Latin for fire, are formed when molten rocks, either magma or lava, cool and harden, or solidifies. They are the most abundant type of rock. Igneous rocks may also be classified based on origin, which is how they are formed, and composition, which depends on the kind and amount of minerals it contains. Here are the types of igneous rocks based on their origins, or on how they are formed. The intrusive, or plutonic rocks, and the extrusive, or volcanic rocks. Intrusive rocks come from molten material beneath the Earth's crust called magma. When this material cools and crystallizes underground, the rocks formed have large crystals. Since the molten material has cooled slowly, this allows individual seed crystals time and space to grow large crystals. The rocks formed are also coarse-grained. The extrusive rocks come from the molten material on the surface of the Earth called lava. As this material cools and crystallizes, it produces small, fine-grained rocks, because it cools quickly. In these extrusive rocks, the minerals do not have a long time to grow large. Rather, as many minerals are crystallizing at the same time, they grow in any spare space around them. Igneous rocks may also be classified based on their composition, or their mineral content. Felsic, or sialic rocks, are silicon-rich. They are also rich in potassium and aluminum, and have little calcium, iron, and magnesium contents. Mafic rocks are silicon-poor rocks. They are richer in calcium, iron, and in magnesium. Then we have those rocks intermediate between the two extremes in silicon content and other minerals. This illustration shows samples of intrusive rocks. They have large crystals, and are coarse-grained. Some have large and small crystals. Those with distinct difference in size of crystals are called porphyritic rocks. One example of an intrusive rock is granite. It is coarse-grained, composed mostly of quartz, alkali feldspar, and plagioclase, and it can be predominantly white, pink, or gray in color. Another intrusive rock is gabbro. It is coarse-grained, composed of pyroxene, plagioclase, and minor amounts of amphibole and olivine, and it can be greenish or dark-colored. Diorite. It is medium to coarse-grained, composed mainly of plagioclase, feldspar with biotite, hornblende, and/or pyroxene. It is usually gray to dark gray in color, but can also be black or bluish-gray. Pegmatite. It is very coarse-grained, composed mainly of quartz, feldspar, and mica. Its crystal sizes usually go from over 5 cm to over 10 meters long. This illustration shows samples of extrusive rocks. They have small crystals, and are fine-grained. One example of an extrusive rock is andesite. It is fine-grained, composed mainly of plagioclase, with pyroxene, or hornblende, usually light to dark gray in color. Another example of an extrusive rock is basalt. It is fine-grained, composed mainly of quartz, feldspar, and feldspathoid. They are usually dark gray to black in color. Obsidian is a fine-grained, volcanic rock, and composed mainly of silicon dioxide, with some magnetite. It is usually dark brown to black color. Pumice, a fine-grained extrusive rock, composed of glass pyroclastic, with bubble walls, and it floats on water. It is commonly pale in color, ranging from white, cream, blue or gray, to green-brown, or black. Sedimentary rocks are formed from broken-down pieces of rock, called sediments. Sediments are smaller pieces of rock in the form of either sand, silt, clay, shells, rock fragments, mineral grains, or dead plant or animal organisms. Rocks are weathered and eroded by water, wind, ice, or gravity. These processes form sediments which are collected into layers. The sedimentary rocks are formed when sediments are pressed, or cemented together, or when sediments precipitate out of a solution. Here is an example of a sedimentary rock. In the Grand Canyon, the sediments harden by compaction and cementation to form sedimentary rocks. In the process of cementation, the dissolved minerals flow between particles and cement them together. Here are the three types of sedimentary rocks. Clastic, the fragments of other rock are compacted together. Chemical, the sediments are glued together by dissolved minerals because of evaporation. Organic, come from fossilized remains of plants or animals. Clastic rocks come from fragments or sediments like sand, silt, clay, pebbles, and boulders, which are cemented together. One example of a clastic rock is breccia. Chemical rocks are formed from minerals dissolved in seas, rivers, lakes, or underground water, and precipitate out forming a solid rock. An example of chemical rock is limestone. This is composed of the mineral calcite, which comes from dissolved calcium carbonate, that comes out of solution as the lake evaporates. Halite and gypsum minerals also form this way. Organic rocks come from fossilized remains of plants or animals, deposited in layers. Bituminous coal and limestone from shells are examples of organic rocks. This limestone forms from the accumulation of shell, coral, algal, and fecal debris. And the bituminous coal forms from the accumulation and preservation of plant materials, usually in a swamp environment. The last rock type are metamorphic rocks. They are formed when existing rock is changed into new rocks, by the intense heating of the rock, and intense pressure from other rocks around it. The term metamorphic comes from meta, which means change, and morphosis, meaning form, in Greek. There are two types of metamorphic rocks. Foliated, in which the crystals are aligned in stripes, or parallel bands. And non-foliated, in which the crystals are arranged in random manner, no bands are formed. An example of a foliated metamorphic rock is the gneiss. Notice the presence of parallel bands. For the non-foliated metamorphic rock, an example is the quartzite. The rock cycle. All types of rocks can be changed into igneous rock by melting and cooling of any rock. Also, all types of rocks can be changed into sedimentary rock by weathering, erosion, sediments compacting, and cementing together. All types of rocks can be changed into metamorphic rock by intense heat and pressure. This constant changes of rocks, from one form to another, is the rock cycle. Here's another illustration of the rock cycle. In here, it is shown that 3 different rocks, basalt, marble, and limestone, may be transformed from one type to another through different processes. Here's another. A sandstone, if it's made largely of quartz, might transform into a granite. If it melts, then cools afterwards. But, if the sandstone is subjected to very high heat and pressure, that it recrystallizes in a solid state, without melting, it will transform into a quartzite, a metamorphic rock. Here's another illustration of the rock cycle. The siltstone, a sedimentary rock, may turn into shale in deeper water, where the suspended clay particles are deposited in larger amounts, and as the current slows down. Then the soft, clay-rich, sedimentary rock known as shale, when subjected to high pressure, becomes a harder metamorphic rock called slate. The slate, that is further metamorphosed, so that very fine-grained white mica achieves a preferred orientation, turns into phyllite. The phyllite is a type of foliated metamorphic rock. Phyllite must then be metamorphosed to form schist. If the schist is metamorphosed further, it might become a granular metamorphic rock, known as gneiss.